Hello everyone, we will now begin our lecture on the final section of chapter 2 on set theory, and this is on the applications of sets. So we will learn how we can apply all that we have learned on sets so far. All right, how that information can be put to practical use in real life. So again, in this section, we will learn how to solve different application word problems, applying the set concepts and using the Venn diagrams that we learned in the previous section. So we will first start with an example where we will need to apply two sets, and then we will go on to problems which involve three sets. All right. So here is the first example that we will work on, and it's on study locations at a college. It says here, at Erie Community College, a survey was taken to determine where students studied on campus. Of those 250 surveyed, it was determined that 167 studied in the library, 138 studied in the cafeteria, and 75 studied in both the library and the cafeteria. So this will be followed by some questions in the next slide, but let me explain what again this is about. So we have here a total of 250 people or students that were surveyed, all right? So 250 represents our universe, all right? It represents the U. And then there are two sets involved. One is those who studied in the library, and we will call that maybe set A. All right, we'll indicate that as set A. And then the other set is those who studied in the cafeteria. So let's indicate that using the letter B. All right, and then there will be a certain number of students who studied sometimes in the library, sometimes in the cafeteria. So the first thing to do is to construct a Venn diagram, because that will help you proceed or progress in answering the questions, the related questions, right? So we have two sets. We have our universe here. So let's just start with a diagram, and in the following slides, we will look into the specific questions they are asking and how to apply the Venn diagram that we will come up with. So again, the rectangular, this rectangular area contains the universe of values, right? And within this universe, there are two sets. One is A. So let me try to draw here one circle, and we'll name that A. And then there is set B, which consists of those studying in the cafeteria, right? So that's our B. And therefore, here we have an overlapping region, an overlapping area. So I'm going to just name the different regions that we have now. We have region 1, and then we have region 2, and then we have region 3, correct? Let me just write that in a straight line, region 3. All right, so let's try to place here all the values we got. It's at 167 studied in the library, right? So this entire blue area will consist of 167 students. And then 138 would study in the cafeteria. So this entire red circle, including the overlapping section, will consist of 138 elements, 138 students. And this middle area, which is the intersection of set A and set B, that means it will consist of students who study both in the library as well as the cafeteria. That would be region 2. All right, so the best thing is to start with the intersecting region, and then it'll be easier for us to figure out how many students we put in area 1 or region 1 or in region 3. All right, so it says here 75 studied in both the library and the cafeteria. So I'm going to put the number or the value 75. Let me just redo this here so I can have some space to write the number. So if this is region 2, we have 75 students belonging in region 2. All right, so region 2 has 75 students, this number here, this number. And then what about region 1? So region 1, so this region here, all right, this region 1 will be 167 minus the 75. All right, so region 1 excludes those students who appear in the overlapping region, in the intersecting region. So you have to subtract that from the total number of students who study in the library. So that would be 167 minus 75, whatever that is, and then to find out how many would fall under region 3. It's the same thing, but this time it's 138 minus the 75. All right, so let's write that 138 minus the 75. All right, so let's go on to the next slide to see what questions we have to answer about this. But now that we have our diagram here, it's going to be somewhat easier. All right, and we are going to revisit this diagram and put in the values belonging in region 1 and region 3 also in the next few slides. So the questions that we need to answer on this problem set are as follows. Of those surveyed, how many people did not study in either the library or the cafeteria? Part B, studied in the library but not the cafeteria, or they studied in the cafeteria but not the library, and then how many studied in either the library or the cafeteria. So essentially, they are looking for the numbers that go in each of the regions. Therefore, if we have our Venn diagram picture with the number of students or number of elements in each of the regions of the Venn diagram, then we just have to pick the appropriate number and use them to answer these questions. All right, so let's go through the next few slides to come up with the solution. So here is a step-by-step workout of the problem through the next few slides. So again, we have our question here, or the data from our question. Of those 250 surveyed, it was determined 167 studied in the library, 138 studied in the cafeteria, and 75 studied in both the library and the cafeteria. So the students surveyed, the total number of students surveyed represents the universe. So cardinal of the universe is 250. Next is the library. What is the cardinal of the library? Students surveyed who studied in the library is 167. Therefore, we write N of L, or the cardinal of L, which is library. They use the letter L to name the set of students studying in the library, and that is 167, right? This number here. And then we have the cafeteria. Students surveyed who studied in the cafeteria is 138. Therefore, n of, or rather the cardinal of C representing cafeteria, that is how the set is named. So n of C is 138, this number here. And finally, the intersection of L and C, library and C, would be 75, correct? So students surveyed who studied in both the library and cafeteria is 75. Therefore, the cardinal of L intersection C is 75. All right. So now with that we have obtained this information, the next step is to come up with a Venn diagram similar to what we had started in the previous PowerPoint slide, and then figure out the regions and put in values in the different regions. All right, so let's go on to the next slide to see what happens next. Now recall that the different cardinals that we came up with, let me write those down here again. N of U, the universe, was the total number of students surveyed, and that was 250. And then the total number of students who studied in the library, that was N of L, was 167. And then N of C, the cafeteria, was 138. And then N of L intersection C was 75, right? So these were the cardinal values that we came up with in the previous slide, and we have to apply these values. All right, we have to use these values to go on to the next step, all right, to put in the numbers in the different regions. So you see over here we have the Venn diagram drawn. The blue one represents the library, the pink one represents the cafeteria, and if there are two sets, then the general form of the Venn diagram of two sets will have three different regions. However, there is always a fourth region which falls outside the two sets. So here we have four regions. Three are within the sets, all right, 1, 2, and 3. 2 is the intersecting or the overlapping region, and there will always be a fourth region which will be outside of the set, part of the universe. That means those elements in region 4 are not a part of set 1 or set 2, or the set of library or set of cafeteria in this case. All right, so we have our regions designated here. We have to plug in these, or rather we have to fill in these different values that fall in each of the regions. All right, so the way to go about that, now that we have our cardinal numbers written, it says region 1 is going to be all values or all elements that are not a part of the overlapping region. All right, so it's best to start with the overlapping region. All right, so when you are filling in the Venn diagram, start by filling in the overlapping region, which in this case is 2. So 2 we know is 75, correct? So the cardinal of L intersection C is 75. So fill in this value first, and then it'll be easier for us to determine what to put in region 1 or region 3. All right, so here it says region 1 is what? 167, right? N of L, all those studying in the library, minus those who study both in the library as well as the cafeteria, therefore N of L intersection C. So you have to do 167 minus 75, which gives a value of 92, and that value goes in region 1. So that's why we have I as 92. 92 plus 75 must give you back the 167. All right, so now what happens with uh, region 2? Let's see. Okay, region 3 is what they work on first. So region 2, we already have that filled in, right? We start with that. So region 3 is the cardinal of C, which is 138, minus the common overlapping region, correct? So 138 minus 75 is 63, and that represents, or that is the number of students who study just in the cafeteria. All right, they never go to the library, they just study in the cafeteria always. Okay, so now that we have all these regions filled up, we have to see if there is anything that falls in region 4. All right, so what we can do is we can sum up the elements in region 1, 2, and 3, the number of elements in region 1, 2, and 3. So 92 plus 75 plus 63. And if we subtract it from the universe, the number of elements in the universe, then we will know if there are any values that fall outside the two sets. All right, and that's what they do next. So in the next step, you add the values, or the number of values in region 1, 2, 3, which gives us 92 plus 75 plus 63 equals 230. So we have 230 elements in as a part of the set. So what is not a part of the set is 250 minus the 230, right? So region 4 is the cardinal of the universe, n of u minus n of L union C. This is union, all right? That means everything that falls in 1 and 3. All right, so and that will give us a value of 250 minus 230, which is equal to 20, and that would be the number we put in region 4. Okay. So here we have the picture of the Venn diagram showing the two sets, one for the library in blue, one for the cafeteria in pink, and we defined the 4 regions, 3 of them inside the circles, and then 4 is outside the circles but a part of the universe. All right, and we also have the numbers here in each of these regions, so it's going to be easy for us to go ahead and pick the right numbers and answer the respective questions. All right, so let's put up or pull up the solutions here one at a time. The first part of the question asked, how many did not study in the library or the cafeteria? So that was the question. They did not belong to studying in the library or studying in the cafeteria. And that would be region 4, right? Those who were not a part of these two sets. And that's 20. So that's why 20 students in region 4 did not study in the library or the cafeteria. The next one said, how many students studied in the library but not the cafeteria? All right, so when we give that number, it involves, or it's just region 1, the number of students that fall in region 1, and that's 92. All right, because the rest of the students in this overlapping circle are those who also studied in the cafeteria. All right, they studied in the library as well as the cafeteria. So the 92 students in region 1 are those who studied in the library and only in the library, but not in the cafeteria. The next part of the question asked how many students said they studied in the cafeteria but not the library, and that includes, or that uh, those are the students who fall only in region 3. All right, they didn't study ever in the library, they only studied in the cafeteria. So That's the 63 students in region 3 are those students surveyed who studied in the cafeteria but not the library. And finally, there was a part D which said the students studied in either the library or the cafeteria. So the students in region 1, 2, or 3 are those students who studied in either the library or the cafeteria. So here they are essentially asking for L union C. All right, so that's why you have to sum up 92 plus 75 plus 63, and that is the number of students who studied either in the library or cafeteria. All right, so this is how we are going to go about solving application problems using Venn diagrams and set theory. All right, so in the next example, we are going to look at one where we work with 3 sets. All right. Now, before we go into working on a problem involving 3 sets, let's go over the strategy that we are going to apply as far as Venn diagrams are concerned. All right. So here it says the procedure to work problems with 3 sets is generally the same. That means we will start with the intersections. We'll start with, of course, constructing the Venn diagram and marking the regions. Remember, there are going to be 8 regions in when we work with 3 sets, when we create Venn diagrams. For 3 sets, there are going to be 8 regions, including the region outside of the sets. And then, in order to fill in the number of values that go into each region, we should always start with the overlapping regions, and we will start with the region where there is an overlap of 3 sets. That would be region 5. All right, so it says start by completing region 5, and I'll quickly draw a diagram to show you where the regions appear, and then next complete regions 2, 4, and 6, then complete regions 1, 3, and 7, and finally complete regions 8. So when you're constructing Venn diagrams, be sure to check your work carefully. So let me quickly draw a Venn diagram with 3 sets marking the different regions. So here we have different sets. So let's say, of course, we have this rectangular shape holds the universe of values, and then let's draw 3 circles here. One a blue circle followed by a red circle, and then maybe a green circle. All right, so we should have 3 circles when we are working with 3 sets. So let's mark the different regions. So we have region 1 is all elements that are part of the blue set only. All right, there's no intersection with any other set. Then the next one, which is an intersection between the blue and the red, is region 2, and then we have region 3, and then we have region 4, region 5, region 6, and then we have region 7, and finally outside is region 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So you see the region 5, the region which is an overlap of the green, blue, as well as the red, is region 5, and we should always start by filling in the elements that go in this region, and then we move out. So region 2 next, region 4 next, the region 6 next. So these 2, 4, and 6 are also overlapping region, but overlap of 2 sets. So 2 is blue and red. 4 is 1 and 7, and 6 is 3 and 7. And then there's the outside region, which is 8, and I don't think I've represented that right. So 5 followed by 3 lines here. So a region 8 will be all elements that are outside of these 3 sets. Okay, so that's the procedure that we are going to follow when we work through an example involving 3 sets. Here's a problem involving 3 sets. The question says Liberty Travel surveyed 125 potential customers. The following information was obtained. 68 wished to travel to Hawaii, 53 wished to travel to Las Vegas, 47 wished to travel to Disney World, 34 wished to travel to Hawaii and Las Vegas, 26 wish to travel to Las Vegas and Disney World, 23 wish to travel to Hawaii and Disney World, and 18 wish to travel to all 3 destinations. All right. So here, as we can see, there are 3 destinations involved. One is Hawaii, the other one is Las Vegas, then we have Disney World. And then the rest of it are intersections between Hawaii and Las Vegas, people who wanted to go to both Hawaii as well as Las Vegas, then Las Vegas and Disney World, and Hawaii and Disney World, and then there were people who wanted to travel to all 3 destinations. All right, so here are the numbers. So what we are going to do next is go through the questions they are asking, and the questions will ask for the number of people who want to go to Hawaii only or Las Vegas only, or to both Hawaii and Las Vegas, and so on. All right, and then once we go through the questions, we will start working on the solutions by first putting together a Venn diagram of 3 sets. Here are the questions they want us to answer on that problem. So how many of those surveyed, remember there were 125 surveyed, did not wish to travel to any of these destinations? All right, so people who had no interest in those destinations, remember, they would not fall under any of the 3 sets. And then how many wish to travel only to Hawaii? How many wish to travel to Disney World and Las Vegas but not to Hawaii? Wish to travel to Disney World or Las Vegas but not to Hawaii? And wish to travel to exactly one of these destinations. I just want to point out here that for question C and D, they look pretty much the same, the wording, except that one has an and in it and the other one has an or in it, because that's going to make a difference on the regions on the answer we provide. All right, and would mean going to both places. It would mean an intersection, whereas or means either Disney World or Las Vegas. So it would mean a union. All right, so we will go through that. We have to keep that in mind when we work through the solutions. So we start solving this problem first by drawing a Venn diagram. We are going to look at this diagram in more detail, but here I have put together the information that we were provided, the data that we were provided on the question, so it will help to have this before us. Now remember that the universal set was the 125 people on whom the survey was administered. So let me put that down here. N of U, that means the cardinal of U is going to be 125. That is not mentioned here. And then we will have 3 sets, all right? We will have N of Las Vegas, and then we will have N of Disney World, and then N of, what was the other one? Hawaii, right? Hawaii. So that information is right here. So let's pull up or first, in fact, before I pull up the solution, let's go over this diagram here. All right, so we have three sets. The blue one is for Hawaii, then we have the pink one for the Disney World, and the black one for Las Vegas. And as you can see, they have 8 different regions. 1, 2, 3. So one is the region that holds people who only want to go to Hawaii and nowhere else. And then 2, it represents the region which is an intersection between Hawaii and Disney World, right? So they want to go to uh, either Hawaii or Disney World. And then we have region 3 for people who just want to go to Disney World. And then 4 is an intersection between Hawaii and Las Vegas, right? So that's region 4. 5 is an intersection of all three, all right? So we have all three uh, destinations, people who want to go to all three destinations. And 6 is people who want to go to Disney World or Las Vegas. And then 7 is people who want to go just to Las Vegas, right? And then the rest, people who do not want to go to any of these destinations, they are not interested in any of these destinations, that would fall under region 8. All right, so I'm going to pull up the solutions one by one. So over here, V is all three, V meaning 5, right? Region 5 is all three destinations, which is the last uh, sentence here. It says 18 wish to travel to all three destinations. So keep in mind, we start uh, by completing or filling in the intersections and start with the ones that is an intersection of all the sets, all three sets in this case. So region 5, and they have explicitly said 18 wish to travel to all three destinations, so we don't have to do any calculations here. We just take this number 18 and put it in region 5. Okay, and then is anything else given to us? No, for the other ones, we have to go through some calculations, right? So let's pull up the calculations here. It says 2 is Hawaii and Disney. So people who want to go to Hawaii and Disney, so that means region 2, correct? So that would be the intersection of region of set Hawaii and Disney. So let's see what comes up. So that's 23 minus 18 is 5. All right. So here we had 23 wish to travel to Hawaii and Disney World. All right. So here this sentence says that, however, you have to be careful. A section of these people also want to go to Las Vegas. Correct. So you have to keep that in mind. We have to subtract that number. So even though they have said here 23 wish to travel to Hawaii and Disney World, there's a catch, because there is a section of that population who also want to go to uh, Las Vegas. So we have to subtract that lot. So 23 minus 18 equals 5, and that's the value we put here. The next one says 4, we have to fill in. So we filled in 18, we filled region 5, region 2. Now we come here to region 4. All right. So region 4 is the intersection between Hawaii and Las Vegas. So to look at here, it says 34 wish to travel to Hawaii and Las Vegas, but there is a section of the people who also wanted to travel to again to Disney World as well, the intersection of all three. So what do we have here? It's 34 minus 18. So even though, again, over here they say 34 wish to travel to Hawaii and Las Vegas, but we have to keep in mind that among these 34, there could be people who also wanted to go to Disney World, right? So we have to eliminate this 18 from the 34. So 34 minus 18 is equal to 16. Now we'll have to see how many we should put into 6. All right. So 6 is the intersection between Disney World and Las Vegas. Right. So let's get that up. So 6 is Disney World and Las Vegas. So that's, let's see over here, 26 wish to travel to Las Vegas and Disney World. However, again, we have that common intersection where people wanting to go to Disney and Vegas could also want to go to Hawaii. So we have to subtract that intersection of all three from there. So 26 minus 18 is 8. That's how we came up with this value, 8. All right. And then 1 is Hawaii only. How do we figure that out? So that's 68, right? Hawaii, 68 wanted to go travel to Hawaii. Minus the 5, Hawaii and Disney, this, minus 18, minus 16. So you see all these intersections that fall within Hawaii, within the blue circle, right? So 1, 2, 5, 4, and 5, they are all within the blue circle, which represents Hawaii, correct? So even though here it says 68 wish to travel to Hawaii, we have to eliminate the 5, the 16, and 18. We have to subtract that, and that's what they do here, 68 minus 5 minus 18 minus 16 for a value of 29. You have to do the same thing when you calculate the number for region 3. So you have to take, so let's see, region 3 is Disney World, right? So 47 wish to travel to Disney World. So you would have to do 47 minus the intersecting areas. So 5, 47 minus 5 minus 18 minus 8 would give us a 16. And finally, for region 7, right? For region 7, you have to, now region 7 is which one? It's Las Vegas, right? So how many wanted to go to Las Vegas? 53 wished to travel to Las Vegas. However, how many wanted to go to Las Vegas alone and they were not interested in the other two destinations? So for that you have to subtract the intersecting numbers, so 16, 18, and 8. So 53 minus 16 minus 18 minus 8, all the intersecting regions or numbers within the black circle. All right. And then finally, you have to, there were 125 in the universal set. So you have to see how much all these sum up to, and then subtract that from the 125 to find the number of people who are outside this set, who are not interested in any of these destinations. Okay. Just to continue with the last two regions, last three regions really, which was not shown on the PowerPoint on the slide before this, region 3 and region 4, and then finally coming up with the number for region 8. So region 3 is Disney only, correct? So what they have done is they've taken the total number of people that wanted to go to Disney World was 47, but the people or the number of people who wanted to go to Disney alone and were not interested in the other destinations would be 47 minus 5 minus 18 minus 8, right? There were a total of 47 people who wanted to go to Disney, but they were a few of them were also interested in going to the other destinations. So you have to subtract that number from 47, and that gave us the 16. And likewise, region 7, which represents Las Vegas, would be 53. So 53 people wanted to go to Vegas, but that number included people who wanted to go to the other destinations as well. So they have subtracted from 53 the intersections of region 4, 5, and 6. All right, and come up with the number 11. And finally, to come up with the number of people who were not interested in any of these destinations, in other words, they were not a part of this set, was 125 minus 103, right? So we have the way we go about it is add all these numbers within the circles, and then you subtract that number, the sum of all these numbers from 125, which is the unit number, the total number, the cardinal number of the universal set. So region 8 is 125 minus 103, right? Sum of all these numbers is 103, gives us 22. So that is, now we have the entire Venn diagram completed, showing not only the regions but the different values that fall under these regions. So now we will answer those questions that they had asked previously on the problem. All right, so far we just drew our Venn diagram and filled all the regions with the numbers. Right, now let's look at the questions one by one. So part A had asked, how many did not wish to travel to any of these destinations? And that would be the number in the region 8, right? Because 22 people were not interested in any of these destinations. So 22 did not wish to travel to any of these destinations. That's the answer. So once you have your Venn diagram, you just need to pick up the right values and or the appropriate values that apply to the question and give the answer. That's all. All right. So the next one says 29 wish to travel to Hawaii only. So the question was, part B was, how many wish to travel to Hawaii? So you have to take the information from region 1. Region 1 represents the number of people who wanted to go to Hawaii only. And then we have, what was the next one? 8 wish to travel to Disney and Vegas, but not Hawaii. So that was the question. I don't remember exactly. It was a few slides back. But the question was, how many wish to travel to Disney and Vegas, but not Hawaii? So what intersection are they referring to? Disney and Hawaii. So that would be Disney and Vegas, but not Hawaii. Sorry. So Disney, and the intersection of Disney and Las Vegas is region 6, correct? So be careful about that. Know what intersection you're looking for. This time it's Disney and Vegas, but not to Hawaii. So that number is 8 over here. All right. And let's see. The rest of it is probably in the next slide. So let me pull that up. Now, part D of the question said, how many wish to travel to Disney or Vegas, but not Hawaii? Now, the previous question had asked us, like part C had asked us, how many wish to travel to Disney and Vegas, but not Hawaii? This time they have the word or, and when we were going through the list of questions, remember I told you to keep in mind that there's going to be a difference in the answers because of the words and or. And refers to intersection and or refers to union. Union means addition. There'll be addition involved. All right, so let's see how we can answer this question. So when we say Disney or Vegas but not Hawaii, it could include 3 things. It could include people who want to go to Disney alone, or people who want to just go to Vegas, not to Disney, or people who want to go to both Disney and Vegas but not Hawaii. All right, so Disney or Vegas. So that's the reason they are adding the numbers in region 3, region 6, and region 7. So it could be people who want to go to Disney World and they're not interested in any of the other destinations, or it could be people who want to go to Las Vegas alone, nowhere else. And then it could also include people who want to go to both Disney and Las Vegas. So 16 plus 8 plus 11, the sum of that, 35, is the solution. And then what would do we have? The last part is it was the question asked how many wish to travel to exactly one of these destinations, and that would be regions 1 plus region 3 plus region 7. All right, how many were interested to just one destination. It could be just Hawaii, or it could be just Disney, or it could be just Las Vegas. Yeah, just Las Vegas, sorry. So it's 29 plus 16 plus 11 is 56. Wish to travel to exactly one of these destinations. So this is how you're going to go about answering the questions, or the application-based questions on Venn diagrams and set theory. But the most important part is to get the Venn diagram drawn, showing all the regions, and then uh, putting the right values that go with the regions from the number of or from the data, from the information provided to us as part of the question. All right.